Unit 1.2, defining limits. Limits can be defined as x approaches, let's call it C, f of x approaches the limit L. So let's start right here. The limit approaches x, or the limit of x approaches 2, fx equals, so look, as the line approaches 2 from either side, 2 is equal to 1, and f of 2 is 1. The limit as x approaches 2, so the graph approaches 2, but you see right here it's an open circle, and that means that it does not equal 2. But the graph approaches, the line approaches 1 on the graph, but it doesn't equal 1. So f of 2 does not exist. Now here, limit of as x approaches 2, so x is approaching 2, its limit, it approaches 1, but there's a closed circle, but there's a dot, there's a closed dot up here, so we could say f of 2 is equal to 3. Use the following graph to evaluate each problem. So the limit as x approaches 1 is -1. F of -3, so this is asking what does -3 equal. It's a closed dot right here, it's an open dot right here. So f of 3, -3 is 0. The limit as x approaches 2, so 2, the line is approaching 2, f of 2, open circle, so the dot is the answer, 3. F of 1, there's no dot, and that's open circle, so does not exist. F of -2, 2. Limit as x approaches 0, 0, -2. Limit as x approaches -3, x approaches -3, 1. Give an interpretation of the statement, the limit as x approaches 7 equals 10. So we can say just as x approaches 7, f of x approaches 10. One thing to remember, a limit does not tell us the value of fx, it just tells us what the function approaches, okay? True or false? F of 1 equals the limit of x as x approaches 1, f of x in all cases. False, because of literally what it says right here. The limit does not always tell you what it actually is at the unit, if that makes sense. I'm sorry about that. Anyways, true or false? F of 1 does not equal the limit as x approaches 1 of f of x in all cases. Also false, because it can equal the same thing.